So we have this problem. Compute the change of internal energy in kilojoules in heating 1 pound mass of oxygen gas from 540 degrees Rankine to 5000 degrees Rankine if its specific heat at constant pressure as a function of temperature is 0.36 minus 5.375 all over T raised to zero point 0.5 plus 47.8 over T in BTU per pound mass degree Rankine. And change of flow energy is 30% of the change of enthalpy. So we have the following given from the problem. Okay, so we have mass. Mass of our oxygen is 1 pound mass. And then we have initial temperature of 540 degrees Rankine. And then T sub 2 or final temperature of 5,000 degrees Rankine. And then we have C sub P as a function of temperature. That is 0.36 minus 5.375 over T raised to zero point 0.5 plus 47.8 over T. This is in BTU or British Thermal Unit per pound mass degree Rankine. And we have change of flow energy or flow work, which is equal to 30% of the change in enthalpy, or that is 0.30 no, of delta H. So required natin, we are asked to find what? The delta U or change in internal energy. Okay. Delta U in gawin natin, that is delta U in kilojoules. Delta U, okay, in kilojoules. So, try natin isolve. Okay, we recall that enthalpy is a combination energy, no? So that is the sum of internal energy plus the flow energy. Consequently, yung change in enthalpy is the same, is equal to delta U plus delta flow energy. Pero ano sabi sa problem mo? Ito, delta flow work or flow energy is 0.30 of delta H. So we have delta H equals delta U plus 0.30 of delta H. So transpose natin, we have delta U is equal to delta H minus 0.30 of delta H. So finally, we have delta U is 0.70 of delta H. So let this be my equation number 1, no? So isod natin. Okay. Now, for delta H also, kung gagamit tayo ng microscopic analysis, so we have delta H is equal to mass times delta H, no? And H, we recall, H is Cp times differential temperature. So to get delta H, integrate natin to from T1 to T2. So delta H is equal to mass times the integral of Cp dt from temperature 1 to temperature 2. So make sure that our C sub P is a function of temperature, which is yun nga yung nangyari kasi yun yung given. So we have delta H is equal to mass times the integral of Cp. We have 0.36 minus 5.375 over T raised to 0.5 plus 47.8 over T, then dt. From T1, our T1 is 540 to 5,000. Palitan ko na yung M natin. Okay. So yung M natin is 1. Mass natin is 1. So that is 1 times this 1. Tama? So anong unit nito? So we have pound mass for M, and then this one, ang unit nito ay BTU, BTU per pound mass degree Rankine times yung dt natin is degree Rankine. Sorry, Rankine pala. So cancel out na ito. Cancel out na to. So matitirang nating unit dito is BTU. So actually, pwede nyo na itong i-punch sa calculator. No? Yung T, gagawin nyo lang X kasi ang nakalagay sa integral function ng calculus natin is ganyan. No? Diba? Then, dx. Tama? So, ang gagawin mo is, punch mo lang to sa calculator. Make sure that gawin mo lang tong alpha x. No? And then, yung the rest, ganun na. Then, hit mo equal sign, lalabas na yung sagot. So, we have delta H is equal to, i-hit ko na to directly sa calculator. I have 1,201.652466 British thermal unit. Okay? So, we can now compute for our delta U. So, hence, from equation 1, we have delta U is equal to 0.70 of this one, 1,201.652466 British thermal unit. However, ang kailangan natin is in kilojoules. So, ang gagawin natin, multiply tayo ng conversion factor. So, we have for every 1 British thermal unit, you have 1.055 kilojoules. So, cancel out na ito. So, matitirang unit is in kilojoules. So, finally, you have delta U of 887.4203.463 kilojoules. So, ito po ang sagot sa problem na yan.